It is recording, I think. Yes or no? You observe? Is it recording or not?
Yes, sir, recording.
Yes, sir.
Okay. All of you listen to me carefully. Here next one is here next topic, that is reduction of matrix to diagonal form. How to reduce the given square matrix into diagonal form? Into diagonal form. Here reduction of a matrix to diagonal form. Okay, about this one, before we should know some basic definitions. Okay, about, before diagonal form, we should know some basic definitions. After that one, we can discuss about diagonal form of a square matrix. Okay, here all of you listen to me carefully. What is similar matrix? What is similar matrices? What is similar matrices? Here similar matrices means, here remember this definition, Anna. Let capital A and capital be square matrices of same order. Square matrices of same order. The matrix A is said to be similar to matrix B, similar to the matrix B, if there exists a non-singular matrix P such that A is equal to P inverse P inverse BP, or PA is equal to PA is equal to BP. Okay, if this condition satisfied, then A is equal to B. Okay, A is equal to here A and B are the similar matrices. A and B are the similar matrices. Listen to me once again. A and B are two square matrices of same order. The matrix A is said to be similar matrix to the matrix B if there exists a non-singular matrix P. If there exists a non-singular matrix P such that A is equal to P inverse B into P. Okay, what is P? That is we can discuss now. You wait for some time. Here P is the non-singular matrix. Any non-singular matrix you can take. Okay, here we can form one non-singular matrix by eigenvectors. How to form that one? That is we can see in next. Okay, here A is equal to P inverse BP. P inverse BP, that one, or PA is equal to PP. It is the similar matrices definition. I think you understood. Next, two similar matrices have the same eigenvalues. Okay, two similar matrices A and B are two similar matrices means that to have same eigenvalues, okay, that is you should remember. Next, what is diagonal matrix? What is diagonalization of a matrix? Okay, what is diagonalization of a matrix? That is you should know. Here a square matrix A is diagonalizable if it is similar to diagonal matrix. A square matrix A is diagonalizable if it is similar to a diagonal matrix. That is, there exists a non-singular matrix P. There exists a non-singular matrix P such that P inverse AP is equal to D. Such that P inverse AP is equal to D. You should remember this condition, Anna. We can use this one only to find diagonalization matrix. Okay, here P inverse AP is equal to D. Okay, here where D is diagonal matrix, where D is diagonal matrix. What is diagonal matrix? Diagonal matrix means except principal diagonal elements, remaining all are the
All elements
zeros.
are zeros.
Zeros. That is the diagonal matrix. That is where D is diagonal matrix. Here P is known as modal matrix. Here P is known as modal matrix. P is known as modal matrix, and D is known as spectral matrix. Spectral means what, Nana? Spectral means what? Already we discussed about this one. Already I given. Okay, very
Set
good.
of eigenvalues.
Very good, Nana. Here D is known as spectral matrix. That means here principal diagonal elements are the eigenvalues. Principal diagonal elements are the eigenvalues. Okay, here D is known as spectral matrix of A. Okay, since similar matrices have the same eigenvalues, the diagonal elements of D are the eigenvalues of A. Diagonal matrix, here diagonal elements of D, diagonal, that is principal diagonal elements of D are the eigenvalues of A. Just now only I told about that one. Okay, here it is a generally you should remember here what is model matrix, what is P, that is also we can discuss now. Here theorem, you should remember just a theorem statement. A square matrix A of order n is diagonalizable. A square matrix A of order n is diagonalizable if and only if it has n linearly independent eigenvectors. Okay, here what is given now? Here a square matrix A of order n is diagonalizable if and only if it has n linearly independent eigenvectors. Okay, if it has n linearly independent eigenvectors, then it is diagonalizable. Okay, that is you should remember. Okay, already we know about that one. Okay, next here what is a note? You should remember these notes also. A square matrix A of order n always n linearly independent eigenvectors. A square matrix A of order n has always n linearly independent eigenvectors when its eigenvalues are distinct. Okay, already you know. Okay, here eigenvalues, for example, 1 2 3 are eigenvalues, nana. Here we can get three linearly independent eigenvectors, right? Yes or no? That is already we discussed. If 1 to 3 are linearly independent, here three distinct eigenvalues, then we can get the linearly independent eigenvectors, right? Yes or no?
Yes, sir.
Boys no response, boys no response. No, no, is my voice audible for you? Boys, are you there?
Yes, sir.
Here,
Yes, sir.
here linearly independent eigenvectors. Linearly independent eigenvectors. If you say, if we have distinct eigenvalues, then we can get the linearly independent eigenvectors. That is already we discussed in class only. In offline classes only we discussed linearly. Here distinct eigenvalues means we can get the linearly independent eigenvectors. Linearly independent eigenvectors, that is already you know. Okay, here next, for every eigenvalue lambda of matrix A, the geometric multiplicity, okay, it is already we discussed geometric multiplicity. Geometric multiplicity what, nana? Geometric multiplicity is less than or equal to algebraic multiplicity. Algebraic multiplicity means what? What is algebraic multiplicity? Any one of you please tell me.
Repetition of eigenvalues
Very good.
many
Repetition
times.
of eigenvalues. For example, 1, 2, 3. Here, how many times repeated this? One time only. Okay, one time only. 1, 2, 3 means one time. What is the algebraic multiplicity for 1, 2, 3? For 1, 1 only. For 2, 1 only. For 3 also 1 only. That is the algebraic multiplicity. For that, what are the linearly independent eigenvectors? Corresponding eigenvalues, what are the linearly independent eigenvectors? That are the geometric multiplicity. That is the geometric multiplicity. You should remember this one also. Geometric multiplicity is less than or equal to algebraic multiplicity of lambda. Next, here a square matrix A is diagonalizable. A square matrix A is diagonalizable if and only if geometric multiplicity is equal to algebraic multiplicity. Okay na? Geometric multiplicity is equal to algebraic multiplicity ante ఆ కండిషన్ సాటిస్ఫై అయితే then here diagonalization possibility is there for that matrix. Okay na? algebraic multiplicity is equal to geometric multiplicity అయిందనుకోండి, then we can get the diagonalization matrix for the given matrix. I think you understood. మీకు అర్థం కాకుంటే ఈ కండిషన్ చెప్పమంటే మళ్ళీ చెప్తాను. ఆల్రెడీ we discussed in first class of eigenvalues and eigenvectors. Already we discussed about this one. Okay, here all of you listen to me once again. Algebraic multiplicity means, ikkada vinandi, algebraic multiplicity means, for example, 1 2 3 are 1 2 3 4 are the eigenvalues nana. Algebraic multiplicity means here how many times repeated. Here what is the algebraic multiplicity of 1 nana?
1.
How many times it is repeated? What is algebraic multiplicity of 2? 1 only.
1.
What is algebraic multiplicity of 3? 1 only. What is algebraic multiplicity of 4? 1 only. But here these are all distinct. Distinct means for that here we can get linearly independent of these three. Okay, here geometric multiplicity of 1 and only for this only one eigenvector we can get. So geometric multiplicity is 1. Here also geometric multiplicity of this one is also 1. Geometric multiplicity of 3 also 1. Geometric multiplicity of 4 also 1. Here algebraic multiplicity is equal to geometric multiplicity. So diagonalization possibility is there for these. If we get like this, diagonalization possibility is there. Sometimes we may get repeated eigenvalues now. 2 to 3 అనుకోండి, 2 to 3 వచ్చినప్పుడు here what is the algebraic multiplicity of 2 nana? What is the algebraic multiplicity of 2? How many times repeated it is?
3.
What is the algebraic multiplicity of 2? 2 to 3 ante what is the algebraic multiplicity of 2?
2.
2. ఎన్నిసార్లు రిపీట్ అయింది? 2 సార్లు రిపీట్ అయింది 2. ఓకే, సో వాట్ ఈస్ algebraic multiplicity of 1 3?
1.
Okay, here ikkada, here for this, here we can find for repeated eigenvalues also we can find the eigenvector. Okay, sometimes maximum, in maximum cases we can get two eigenvectors. Two eigenvectors we got means here how many linearly independent eigenvectors we got? 2 we got. So algebraic multiplicity is equal to geometric multiplicity, right? So for this also diagonalization possibility is there. Here 3 for 3 means that is a distinct means, for that you can get the one eigenvector, linearly independent eigenvector. Okay, here it is the algebraic multiplicity and geometric multiplicity. It is the algebraic multiplicity and geometric multiplicity. I think you are all of you. I think you understood this one. Yes or no? All of you okay now?
Yes, sir.
Boys, ఉన్నారమ్మా? Boys, anyone is there?
Yes, sir.
మరి ఒక్కదానికి కూడా రెస్పాన్స్ ఇవ్వరు ఏందరా నాయన, నిద్రపోతున్నారు పోయి. ప్లీజ్ గివ్ మీ రెస్పాన్స్ ఇవ్వండి అడిగినప్పుడు. ఓకేనా? ఇట్ ఈస్ ద జంప్. ఓకే, to get a diagonal matrix, okay, it should satisfy this condition nana. It should satisfy this condition, that is algebraic multiplicity is equal to geometric multiplicity of given eigenvalue of a. Algebraic multiplicity is equal to geometric multiplicity should satisfy, then only diagonalization possible for the given matrix. You should remember that one. Okay, while discussing problems easily you can understood. Listen carefully. Next, what is the procedure to find diagonalization and calculation of powers? Okay, here by using, if it is diagonalizable, okay, here we can find the powers of the matrix also. How to calculate powers and diagonalization, that is we should know. Listen to me carefully. Nana. First, find eigenvalues and corresponding eigenvectors. It is yes or no?
Yes, sir.
Okay. After this one, you find eigenvalues and corresponding eigenvectors of A. You should complete that one. After that one, you need to observe one thing, only one condition, that is geometric multiplicity is equal to algebraic multiplicity for every eigenvalue of A. Okay. Geometric multiplicity is equal to algebraic multiplicity for every eigenvalue of A. Then form the model matrix. Form the model matrix అంటే ఏంటంటే here P is equal to మనకు P is equal to we need to form model matrix. For example 3 by 3 matrix అంటే మనకి ఏమొస్తుంది నాన్న 3 eigen vectors వస్తాయి కదా. Here we can get 3 eigen vectors. The 3 eigen vectors we need to arrange in the column wise. We need to arrange in the column wise. We need to arrange in the column wise like this. Okay, like this column wise we should arrange that that matrix is said to be model matrix, Nana. That matrix is said to be what? Model matrix. Okay, here we need to form the model matrix. What is that one? Here we need to arrange the eigenvectors corresponding to the eigenvalues. We need to arrange in the column wise like this. Okay, here I given 3 colors, right? Okay, first eigenvector, second eigenvector, third eigenvector, these 3 we need to arrange in the column wise. Okay, after that one, here we need to find here inverse of the matrix. Inverse of the matrix, how to find inverse, that is okay, if we know some matrix means, for that we can write the inverse by using calci. You write that one. After that one, here we can write the diagonal matrix. We can write the diagonal matrix. How to write diagonal matrix? P inverse A into P. A means that is the given matrix. It is a given matrix. P inverse means from the model matrix we can write into P inverse AP. Okay, by multiplying these three, 100% you can get diagonal matrix. Diagonal matrix ante eigenvalues ఏ వస్తాయి మనకి. Principal diagonal elements are eigenvalues. Remaining all are the zeros you can get. Okay, here principal diagonal elements are the eigenvalues. Remaining all are the zeros you can get. Okay, zeros you can get. That is the here diagonal matrix. That is the spectral matrix. That is the spectral matrix of the given matrix A. I think you understood up to here. Okay, now all of you. Okay, now
Yes, sir.
boys, are you there, Nana?
Yes, sir. Okay, sir.
Okay.
Yes, sir. Okay, sir.
Here, after completion of diagonalization of the matrix, here we need to find the here powers of the matrix. Here powers, how to find powers? That is also you should know. Here it is very easy, Nana, to find powers. Here that is you should remember. Here diagonal matrix equal to what? Here diagonally D is equal to P inverse AP, right? D is equal to P inverse AP. Okay, pre multiply with P and post multiply with P inverse for the equation number 1, Nana. Pre multiply with P and post multiply with P inverse. Then you can get like this. You can get like this. Take it as equation number 1. Here what we got now, P into D into P inverse equal to A we got, right? Then what is the A square? A square means A into A into A. That is P into D into P inverse into P into D into P inverse. Like this we can write. By associative law, we can write like this. Can I solve here? Shall solve చేయాలా? Solve చేయాలా?
Yes, sir.
Okay,
చేయండి సార్.
here D is equal to what, Nana? What is D? D is equal to P inverse AP. Okay na?
P inverse AP.
Okay, now pre multiply with P and post multiply with P inverse. P pre multiply with P and post multiply with P inverse. అంటే ఏమవుతుంది ఇక్కడ P into D into P inverse. That one is equal to P into P inverse. ఇక్కడ it's a same both sides we should multiply, right? Pre and post multiply with P and P inverse. So we can get like this P inverse. Okay, P, this one is equal to what we can get now? P into D inverse P inverse equal to here. What we can get for this? This one is equal to I, this one is equal to I. That means what we can get? A you can get. A you can get. Yes or no? Now here it is, you remember this one. Next, from this we can write the A square. A square is equal to what, Nana? A into A. A into A means here P into D into P inverse into again P into D into P inverse. By associative law we can write like this, Nana. Here P into D into P inverse into P into uh, D, okay, into P inverse, right? Can we write like this? Yes or no?
Yes, sir.
Okay, now that one is equal to, here P inverse into P means
P
that one is equal to I, right? I, here I into D means I D only. So D
D.
into D square you can get in middle. D square into P inverse. Okay, here it is the A square. Okay, it is the A square value. Similarly, A cube also you can write. A cube means P into D cube into P inverse you can get. Here A power 4 is equal to P into D power 4 into P inverse you can get. Like this you can calculate up to nth order. Okay, up to nth power, up to nth power. Here it is the general, by using this formula we can find the powers. We can find the powers of matrix. Here D power 4 అంటే ఏంటన్నా, ఫర్ ఎగ్జాంపుల్ ఇక్కడ D అంటే మనకి ఈ విధంగా వస్తుంది. How we can get D means here 1 0 0 0 2 0 0 0 3, like this we can get D means. Here D power 4 అంటే it is very simple, right? Here 1 power 4 0 0 0, 2 power 4 0 0 0, 3 power 4. Okay, just to find powers of only principal diagonal elements means it is very easy, very easy. Okay, D power 4 in generally for different, for 3 by 3 for 3 by 3 matrix to find power 4 means it is somewhat difficult, but here it is a diagonal matrix. Diagonal matrix, so here powers just we need to power only for principal diagonal elements. Okay now, here what is P, what is P inverse? No need to calculate this one, just directly you can enter in the calc, you can get the powers. You can get the powers. Here just you should know the formula. You should know the formula, that is you should remember. Okay, I think you understood this one, right? All of you okay now? All of you okay now up to here?
Okay, sir.
Okay, now we can see one example on this. It is the total diagonalization introduction. Next, one example we can discuss now. All of you listen to me carefully. Up to here, okay, now all of you? Up to here, okay, now all of you? Hmm. Now, write one problem. A problem ఇద్దాం. Write down. $55 వచ్చినారా?
వచ్చిన సార్
55 ఓకే, నా లాగిన్ అయిందా?
సరే
ఏదైనా ఉంటే డైరెక్ట్ నన్ను అడగండి రా భయ్. వానికి ఇచ్చి వీనికి ఇచ్చి పరిచయం అయ్యేది ఎందుకు మీరు? నేనేమన్నా కొడుతున్నా మిమ్మల్ని? కొడుతున్నానా? అది నిన్నే వచ్చింది నాకు. ఓకే, write this problem, all of you. All of you write this one. Find the matrix P which transforms the matrix A to diagonal form. Hence, calculate A power 4. Okay, here what we need to find P. P means what is P, Nana? Just now only we discussed now. What is P here?
Model matrix.
Model matrix. Model matrix means
Set of eigenvalues.
No. Here model matrix means here we need to write eigenvectors in column wise. Okay, first eigenvector we should write as first column. Second eigenvector we need to write second column. Third eigenvector we need to write as third column. Okay, now write down. All of you write down carefully. Solution. The characteristic equation is, or the characteristic equation of capital A is determinant of A minus lambda I, that one is equal to 0. That is, tell me Nana, here all of you write the characteristic equation first. The first, that is 1 minus lambda 1 3 1 5 minus lambda 1. All of you be ready with calci. Next 3 1 1 minus lambda, 1 is equal to 0. Now that one is equal to 0 I written here. That implies here we know procedure to find the characteristic equation. That is, first one is lambda cube minus trace. What is the trace here? 1 plus 5 plus 1 into lambda square. Next place here what is the next one here? Minors of principal diagonal elements. We need to leave first row for this first row, first column, first column we need to leave. Then what is the determinant of next one? That is 5 1 1 1. Next one, whatever next one plus here we need to leave second row, second column. Then determinant, what is the determinant? 1 3 3 1. Next we need to leave third row, third column, third column we need to leave. So here what we can get, what are the values? 1 1 1 5 here into lambda minus delta A, that one is equal to 0. Here what are the values? Tell me first. Lambda cube minus 7 lambda square. Next determinant values, tell me Nana. 5 minus 1 4. Next
4
place. Here what is the next value?
minus 8
Here 1 minus 9, that is minus 8. Very good. Next one, what is the next one? 5 minus
4
1, that is 4, that into lambda minus delta A. What is the determinant of
minus
here?
36
Minus 36. Very good. Good girl.
6
That one is equal to 0. Equal to minus 36. Okay, next here at last what we got? Lambda cube minus 7 lambda square plus 36, that one is equal to 0. Here how to find roots for this? That is already you know. Here what are the eigenvalues? Tell me.
Minus 2,
Find
6
the
and 3.
minus 2.
minus 2
Okay, minus 2 3 6. Okay, can I write like this? Okay, you can take any order, no problem. Here these are the distinct, right? These are the distinct eigenvalues. Therefore the eigenvalues eigenvalues of capital A are eigenvalues of capital A are minus 2, 3, 6. These are the eigenvalues. Next, we need to find eigenvectors. Okay, if these are the distinct, then what is the procedure? That is already we discussed. That is when lambda is equal to minus 2. When lambda is equal to minus 2, system the system one second, all of you do it. Nana, already you know now. When lambda is equal to minus 2, the system a minus lambda I into x equal to 0 becomes, tell me here how it becomes. Tell me, Amma. Any one of you please tell me. Here first, by putting when
3.
lambda is 3,
3.
1, 1, 3, 1, 7, 1, 3, 1, 3. ఫస్ట్లో మంచి రెస్పాన్స్ ఇచ్చేది. ఒక్కొక్కరు ఇప్పుడు అప్పుడే మన వాళ్ళు అయిపోయారు కదా. ఓకే, x1, x2, here that is equal to 0, 0. Is my voice audible for you?
Yes, sir.
Yes. Okay, here we got like this, right? Here after that one, what next? Tell me. What next? Here solving for x1, x2, x3. Here here we need to fix first row. Nana, by fixing first row we can get the values. That is x1 by what is the procedure for us? X1 by, we need to leave this column and first row fix
21.
first row. Okay, here tell me. Here that is 7,
7,
1,
1, 1,
1,
3.
1, 3. Next, x2 by minus of
1, 1, 3, 3.
1, 1, 3, 3. Boys, x3 by here 1, 7,
3, 1.
3, 1. Okay, now that one is equal to, here what we can get now? X1 by here 21 minus 1, then x2 by minus of 3 minus 3. Next, x3 by 1 minus 21. Then that implies here x1 by 20, x2 by 0, 0, here x3 by minus 20. 21s are 20, here 0, here 20, 1, here minus 1 you can get. After this one, what is the eigenvector, Nana? What is the eigenvector here? Tell me. That implies
1, 0, minus 1.
x1 by 1, x2 by 0, x3 by minus 1. Okay, thus x1 is equal to first eigenvector. We can denote x1, that is 1, 0, minus 1. 1, 0, minus 1 is the eigenvector corresponding to the eigenvalue lambda is equal to minus 2. Lambda is equal to minus 2. Here for minus 2, how many eigenvectors we got, Nana? For minus
1.
2, 1. So algebraic multiplicity. So algebraic multiplicity is equal to what? Geometric
Equal
multiplicity,
to
right?
geometric multiplicity.
Geometric multiplicity. Okay, here algebraic multiplicity. Here it is generally denoted by like this. Algebraic multiplicity of minus 2 is equal to 1. That one is equal to geometric multiplicity, MULT suffix G of minus 2. Okay, now both are equal only, right? Here you need to observe this one. Next one. What about next one? When lambda is equal to, when lambda is equal to, what is the next eigenvalue, Nana? When lambda is equal to 3, the
3.
system A minus lambda I into x equal to 0 becomes, okay, tell me, Amma, tell me, it becomes here, tell me, what we can get by putting minus 3? 3 minus 2, 1,
Minus 2, 1, 3,
3, hmm,
1,
1
2,
to
1,
1,
3,
3,
1,
1,
minus 1,
minus 2.
minus 2.
Minus 2 or minus 2 into x1, x2, x3, that one is equal to 0, 0, 0. Okay, here we need to solve this one again. Here fix first row only, fix first row only. By fixing first row you can solve this one. Okay, then tell me, Nana, your first for solving for x1, x2, x3. Here first one, what is the first one, Nana? X1 by, leave the first row and first column, then 2, 1, 1 minus 2, then x2 by minus of, here leave first row and second column, that is 1, 1, 3 minus 2, leave first row and third column, then what we can get, Nana?
1, 2, 3.
1, 2, 1, 2, 3, 1. Okay, here just to find the determinant for this, that implies x1 by minus 4 minus 1, x2 by
5.
minus of minus 2 minus 3, next x3 by 1 minus 6. Then what we can get, that implies x1 by minus 5, x2 by 5 minus 5 plus 5, you can get x3 by minus 5, 5 ones are minus 1 here, 1, here minus 1. Then at last that implies here x1 by what, Nana? Minus 1, x2 by 1, x3 by minus 1. Then thus x2 is equal to what? Here 1 minus 1, 1 is the eigenvector corresponding to the eigenvalue, the eigenvalue, enti eigenvalue, the eigenvalue
3.
lambda is equal to 3. Okay, now lambda is equal to 3. Here you should observe one thing. Here what is the algebraic multiplicity of 3? What is algebraic multiplicity of 3? Algebraic multiplicity of 3 is equal to how much?
1.
1. 1.
3 is equal to 1. That one is equal to geometric multiplicity. How many linearly independent eigenvectors we got for this?
1.
1.
1 only. That one is equal to 3. Okay, that is you should observe. Okay, now next, what about next one? Here when lambda is equal to, when lambda is equal to what? 6. When lambda is equal to 6, the system A minus lambda I into x equal to 0 becomes ఏమవుద్ది నాన్న becomes tell me
minus
tell
5, 1.
minus 5.
-5 చాలా స్లోగా చెప్తున్నా అర్థం చేసుకోండి ఓకే -5 3 -1 -5 1 3 నెక్స్ట్ 1 -1 1 నెక్స్ట్
Sir.
Yes, sir.
3
3
3
1
1 -5
minus
okay x1 x2 x3 then that one is equal to 0 0 0 okay solving for what solving for here x1 x2 x3 solving for x1 x2 x3 here also fix first row nana here also fix first row then what we can get x1 by all of you do it and tell me fix first row and tell me the values x1 by leave first row first column then 1 minus 1 1 1 minus 5 then leave first row second column here minus of then 1 1 3 minus 5 next leave first row third column then what we can get 1 minus 1 3 1 here that implies here x1 by here 5
4.
minus 1 next x2 by minus of minus 5 minus 3 next x3 by 3 plus 1 then that one implies x1 by 4 x2 by here what we can get nana x2 by 8
8
x3 by 4 then 4 ones are
4
4 twos are 4 ones are then what we can get x1 by 1 x2 by 2 x3 by 3 x3 by 1 only not 3 then at last right here what is the next one Anna here thus x3 is equal to 1 to 1 1 to 1 is the eigenvalue is the eigenvalue corresponding to the eigenvalue eigenvector కదా ఇక్కడ ఇక్కడ కూడా సప్పుడు చేయట్లేదు నేను ఏం రాసినా రాస్తా ఈజ్ ద eigenvector
corresponding to
corresponding
the
to
eigenvalue 6.
eigenvalue lambda is equal to 6 okay here what is the algebraic multiplicity nana here
1
multiplicity of algebraic multiplicity of 6 algebraic multiplicity of 6 is equal to 1 that one is equal to geometric multiplicity of 6 okay independent eigenvectors we got only one now here just I am writing model matrix remaining we can discuss in next class okay write that model matrix here write down the model matrix P the and also find the inverse all of you the model matrix is P is equal don't think much about this one Anna what is the first eigenvector tell me Amma what is the first
1 0
eigenvector
minus 1
1 0 minus 1 what is the second eigenvector
minus 1 1 minus 1.
1 minus 1 1 I taken minus common is there any change minus
No,
common issue next what about next one 1 2
1
1
2
okay
1
okay it is the P right what is the inverse like this write down that one is equal to here I am writing x1 x2 x3 okay that means these are the eigenvectors we written as column wise right yes or no now then what is the P inverse you should tell P inverse nana ఎంతమంది చేస్తారు చూస్తాను calci by using calci you tell me P inverse by using calci all of you find P inverse and tell me Okay, within 5 minutes I will complete this one. Plus we can write the diagonalization also. You tell
1
me P
by
in
2,
good girl 0.
0, minus 1 by 2,
Okay, good.
1 by 3,
Okay, good.
minus 1 by 3,
Good.
1 by 3,
Okay, ma.
1 by 6,
Okay.
1 by 3,
Okay.
1 by 6.
Good girl. Keep it up. Okay, here it is a P inverse, right? Here I am telling one point, listen to me carefully. The diagonal matrix is given by, what is the formula, Anna? Just now only we discussed now. The diagonal
P inverse AP.
P
matrix is given by simply remember like this, Nana. D is equal to P inverse AP.
AP.
Okay now. Okay, just you write the P, Nana. P inverse. What is P inverse? That is just now only we got 1 by 2 0 minus 1 by 2. Next our enti meeku?
ECS.
Okay, 1 by 6, 1 by 3, 1 by 6. Okay, next what is A? Okay, A matrix, given matrix రాయండి. Given matrix రాయండి. A matrix. Next after that one, P. Okay, that is also right here. Okay, you remember one thing, Nana. మనం ఏ ఆర్డర్లో రాసినాము? ఐగన్ వెక్టర్స్ ఏ ఆర్డర్లో రాసినాం నాన్న? ఫస్ట్ -2కి చేసినాం, నెక్స్ట్ 3కి చేసినాం, నెక్స్ట్ 6కి చేసినాం కదా. You should follow that order only. Directly you can get this one like this only, Nana. -2 మీరు ఏ ఆర్డర్లో తీసుకుంటే ఆ ఆర్డర్లో డయాగనల్ మ్యాట్రిక్స్ రాయాలి. 006. That's it. By multiplying these three, you can get this one only. No need to multiply the three. Directly you can write this one. Okay na? Okay na? All of you okay na?
Yes, sir.
I think you understood. Boys and girls, all of you okay na? All of you okay na? This one. Girls, no response. Only one girl giving response. Boys, only one boy giving response. Remaining all are in sleeping mode. నిద్రపోతుర్రు, అప్పుడే పెద్దోళ్ళు అయిపోయారు. Right?